At this point, I hope that you are beginning to understand that everything in R is an object. This includes variables, functions, and packages, whether written by you or a different user. These objects interact with each other to uncover useful information about the inputs put into the program. Basically, objects work on inputs to become objects. So far, we have talked about individual objects like simple variables. If I assign x to be 15, we now have an object, which is a single value, which is 15. We call it by using the tag x. What if we want more than one variable or one object to exist inside the x object? Let's introduce a new type of object, which is known as a vector. Define a vector using this C function. And we can enter in as many different values as we want, separated by commas. So now vec is a numerical vector. So whenever I enter it into the console, it's going to return the series of numbers 1 through 5. This is the simplest data structure we can have. It describes a group of things, and in this case, numerics. You can think of the C function as sort of like combining objects. In this case, it just simply grouped together the integers 1 through 5. We've entered 5 different arguments into that function, and there is a limit to how many arguments you can add. It's an extremely high number, like 2 to the 31st power. We can use the class function to get a little more information about the vector that we just created. The class function will tell you what is in that object, and in this case, it's all numerics. Now, we could create this same vector with less typing. So instead of using the C function and listing out each integer 1 through 5, we can just enter 1:5. What 1:5 does is it gives you the range of integers from 1 to 5. So if I do 3 through 7, it's going to return 3, 4, 5, 6, 7. This is very helpful notation, and we'll use this quite a bit. It also works for decimals. So if I do 1.5 through 5.5, it's going to return from 1.5 to 5.5, iterating by one integer at each point. The difference between each object in this vector is going to be 1. Our original vector has 5 objects. We can easily subset this vector by using square bracket notation. And if I enter 1, it's going to return the first value in that vector. I'm going to create a new one real quick just to make it more apparent what's going on. So I'm going to create a vector that's the integers 10 through 15. And we can see it here now. And let's look at that square notation again. If I enter 1 into square bracket notation directly after the object name, it's going to return the first object of that vector. If I enter 3, it will return the third object, which is 12. Now we can use that same colon notation that I showed you before. If I enter 1:3 into the square bracket notation, it's going to return the first 3 objects of that vector. Similarly, if we enter a -1, it will return everything except the first object. If I do -3, it will return everything except that third object. So you can see that it skips 12. And if you want to skip a whole portion, you can do the 1:3 in parentheses and have a negative sign sitting right outside of it. That's going to return the last 3. Creating a vector by entering either a range or individual numbers is rather straightforward. We can even enter vectors into vectors or user-defined variables into vectors. So let me create a few vectors real quick. So I created 2 vectors and z, which is just a single number, 100. Now I can create a vector using the C function again and throwing these all into it. So I'm going to be combining 2 vectors and a single value. And now our vector is bigger. Contains 1, 2, 3, some decimals, and the value 100. How about instead of z, I want the range of numbers from -3 to -1. Length is a very useful function when dealing with these vectors. It tells us the number of elements that are inside of it. So if I do length of my vec, it's going to return 9. We can also create vectors out of strings. So if I do car vec, this is going to be a character vector. And I'm going to enter in the strings hello, hi, and sup. We can also do Boolean vectors. So if I do boo vec, I can do true, false, true, true. Now, if we try to create a vector out of numbers, strings, and booleans, they're all coerced into strings. Here's the combine function. I'm going to try to enter a number, a string, and a boolean object, a true. Now, when you do that, the only way to have all these objects be the same class is to do what's called coercion. It forces those objects to all be strings because they can all exist as strings. But for example, this object high cannot exist as a number or a boolean object. Now, an important feature about these vectors is that we can do mathematical operations on them. So let's create our original vector again as the integers 1 through 5. I can do multiplication to this vector. And what it does is it's going to multiply each object by the number 2, as long as they're all numerics. Otherwise, it would fail. I can add vectors together. So if I add it to itself, you'll get the same thing. If I do vec plus 10, it's going to add 10 to each object. I can square them all. Let me create another vector, vec2, which is the numbers 1 through 5. And I'm going to multiply this by 2. So what this is going to do is it's going to give me a vector that's 2, 4, 6, 8, and 10. Now I can do some complex operations to both these vectors. So if I do 3 times vec, my original one, that's 1 through 5, and I add it to vec2 squared, then add another 1, and I divide the whole thing by 10, it will return these values. Basically, for each object, for each variable, so let's say the first object in each vector, it's going to take 1 times 3 plus 2 squared plus 1 divided by 10. Now, what if my vec2 had a longer length? So length of my vec2 is now 6. There's 6 objects in it, while my original vector has 5 objects. Now, if I try to do this operation, it's not going to work. You'll get a warning because one of the objects was longer than the other one. It ends up cutting off the last value that we added to the second vector. In this lesson, I gave you an introduction to vectors, how to create a vector, and how to do different mathematical operations on them. And we're going to be using this information a lot throughout the course.